Okay, so to help us understand it, let's just do a quick recap. If we set up the variable age with a value 10, we can check the ID of the variable. Remember, the ID is kind of the memory location, and there's the memory location. And if I now do age is assigned age plus 1 and reprint age, it's obviously gone up to 11. And if I do the ID of age, what you'll see is it's in a different memory location. So that has basically demonstrated to us one of the misconceptions about programming, that we don't create a memory location, put 10 in, and then change the value in there to 11 and it's the same location. The way Python works is it actually puts it into a new location. Other programming languages work different. Okay, so let's talk about how that works. So we got the variable age. Now remember what a variable is. A variable really is a label to memory. So in memory somewhere we have stored the value 10. It will have created enough space to store that value 10. When we do the command age is assigned age plus 1, we take the value 10 out, we add 1 to it, and that creates the value 11. Even though we teach we put it back into the same bucket, we don't, because we've got no idea whether it will fit or not. So what we actually do is we create 11 in a new memory location, and we just move the label and point it to our new memory location, and that's why the IDs are different. Okay, so it's still there. We've got age, which is the value 11, and the ID of age, that's its memory location, is ending in 3360. If I create a variable called new age and assign it the variable age, and look what new age is, it should come as no surprise that new age is also 11. What we teach is we've created a new variable and we've copied in the value 11. Age and new age are independent variables. However, if we have a look at the ID of new age, it might come as a bit of a shock that it's also ending 3360. It's the same number. So in fact both of these, age and new age, are pointing to the same memory location. So they are not the same, they are not independent variables, they're actually the same variable. However, if I go and change one of them, so I'll actually change maybe age to 20, just check it's changed, it has, just see what happened to new age. Oh, spell it right. New age is still 11, so what in the world has gone on? Let's just have a look at the ID of new age. Oh, that's still there in 3360, but what about age? Age is in now 504, so it's created a new instance. So let's just make sure we understand what went on there. Okay, so we started off with age, and age was a label pointing at somewhere where the value 11 was. When we said new age is assigned the value age, what actually happened, it created a label called new age, and rather than, like we teach, creating a separate copy of that, it basically pointed the label back at where the 11 was stored. So they both have the same value. However, because integers are immutable, whenever I change one of these, it creates a new instance. So when we then went and did age was 20, it didn't change what was in this box here, it didn't change what was in the 11, it basically created a box with 20 in, memory location 20, and it made the label age now point to the new box. So they worked as independent variables. So we even though this is how it works under the hood, we definitely teach this like it creates independent variables, and indeed other programming languages do. This is just the way Python works under the hood.